Nice. All right, well, I can just let people in as they come. So, all right, where do you want me to start? Just kind of,
Personally, I was having issues. So with the whole parameters function as a whole, I'm kind of confused as well as so in like the picture I sent you, I had my graph and it had the two models and the best fit. The one model like was kind of irrelevant. The other one kind of sat right on top of the best fit line. And I guess one of my questions would be why have both if they're kind of sitting on the same spot.
yeah, so, okay. So with the single peak, so let's say that our data, let's see, I've got this, I'm just gonna create some fake data here. I'm gonna just add in, going to change this to just using one Gaussian. Okay, so this is just my fake data. Let's see, what's the other one it's doing here? Oh, yeah, I don't have that one. I just have G0. Okay, so there's my fake data. So it's got some noise on a Gaussian. So we'll try and fit this one. So if you only have one peak like this, then when you're in your sort of general model here, you don't need to have two peaks defined. So this you have to modify depending on what you're trying to fit, right? And these can be pretty much anything that you can define. I'm going to put this all together in one spot. So you can define any functions you want, right? In our case, we just happen to define this Gaussian function. Oops, it's not going to be good. Okay, so we define the Gaussian function, and then here what we're going to do is we're going to basically just tell it what models we want to fit to. And the reason there was two here to start with is because we actually had two Gaussians that were overlapping, right? So I needed to fit a Gaussian to one and a Gaussian to the other. If I generate this set of fake data, just one Gaussian curve, then what I'm gonna do is just go ahead and get rid of one of those so that my my model is just the one. In fact, I can just delete all this, call it model. So now I'm going to fit that data to just one Gaussian curve. Does that make sense?
Yeah, no, that part makes sense.
Okay. And this prefix, if you only have one curve, you don't really need it, but I'm going to leave it because it'll make these things work as they are. But this is just, if you're using the same function to have multiple Gaussians fitting, then they all have the variables a, mu, and sigma in them. And so when you go to set the parameters, you have to have some way to separate which ones belong to which function. And so that's what this prefix does. It just attaches that on to the parameter names so that you know that these are for, the first Gauss, and then this is for the second time you call it. So that's all that's doing. All right, so if we only have one, then I need to get rid of all these. And let's take a look at these for a second. So these parameters, and this is just the way that you import them. There are some shorter ways of doing it. If you look through lmfit, I chose this one because it's the most general, and it'll show you things that you can set if you need it to. But what you got to do is just define the variables, the mean and sigma. And so that's the name piece. The value here, probably should really just call this initial. This is the initial value that you're basically telling it to start with. And then you'll let it go ahead and guess. And so these, you know, we have to sort of figure out based on this what that should be. So in this case, you know, the mean we can see is somewhere, you know, more than 2.5. So you don't have to be close. I mean, you're just telling it whether it's here at 2 or it's, you know, peak over at 300. So we'll just pick like, you know, 3 or 2, anything works. And then the sigma is something like the half width. So if we, you know, kind of roughly look at this one, it looks like we got a width of about 12. So sigma would be something on the order of 6. You know, this one just said 1, so you can see it's not terribly sensitive to that. We can make it 6 if we want and see what happens. And the mean we said was more like 3. And then the amplitude's a little funny on this one. We have to be kind of careful. Well, let me go ahead and fit it and then we'll see what happens. But this amplitude I put in here is way too low. So we'll see if that affects anything. All right, the true here just tells it whether this is a variable that you want it to fit. So this gives you the option of being able to say false in one of these and you're giving it a value and then it won't change that value in your fit. So sometimes you know you have that case. Or maybe you're having a really difficult time, so you want to fix one of them, like the mean, just be close enough, and then have it just fit the other 2 parameters to get close, and then use that case as your next guess. But that lets you do that. So most of the time, this is just true. We want it to go ahead and vary those. Then you could put in a min and a max if you want it to constrain. So in this case, I did have a min and max in for the mean. We really don't need it. So these all could be just none. Sometimes having a min max helps. Expression and brute step probably won't use. The brute step just tells it what step size to use to find the solution. It has its own built-in, so I don't bother with that at all. Just leave it as none. Expression's interesting. Expression, if you get to a problem ever that you need to fit, and you know that there's a relationship between the variables, so maybe you know that, you know, like your mean has to be, the mean of your 1 has to be, you know, twice the mean of another fit if you have 2 fits. Then you can actually put that expression in here. You can tell it that those things have to be equal. So you can do a lot of things with this, sort of sophisticated things if you want to link the variables in some way. But so we won't deal with that either, but you can read on it in lmfit. It's actually pretty neat. All right, but those are our parameters. So we'll go ahead and do that. When you do the one for homework, since most of these numbers are going to be in the hundreds, because we got a big wide peak in that one, it's going to be important to get this amplitude at least somewhat close. And main thing with the amplitude is it's going to be this factor here, right? Sigma times the square root of 2 pi. It's going to be basically that factor times the amplitude that you ultimately want it to have. So like in this problem, it's 20. Okay, so if I take 20 and multiply it by sigma, I'm at like 120. And then if I did the square root of 2 pi, that probably isn't really all that necessary, I guess, but what's the square root of 6? I don't know. Let's just double it. Just call it 2. So that's actually probably a reasonable guess at the amplitude value based on the fact that we picked this at 6. And that just depends on your function. All right. And then what else we got? Okay, so this is based. Yeah.
I think someone may be waiting in the waiting
Julie?
room.
Yeah, Julia. Yeah, I just clicked her in. Thanks.
Okay. Sorry.
No problem. So this is actually the fit itself. So we did all this as setup. This is actually the fit. So it's going to basically take this model. It's going to take the parameters that we gave it as starting points to run our fit, and then the y and x data, of course, we generated back here. It's this noisy stuff. All right, and then after that fit, we'll get a result out. And this one I don't really need here because I only have one peak that we're going to fit to this time. This one here really is if we've got multiple models or things that we're adding together, then this breaks it into components so we can look at each one separately. So we'll look at that when we do the 2 peak one. So I don't really need this, but it doesn't hurt anything. We can leave it in. And then in our case here, we said we're not going to do we don't have a second model. We just have the first. And I'm just making sure that all this is right now since I changed names, but that looks fine.
I have a quick question.
Yeah, go ahead.
Why is there an x equals x in the model fit?
Yeah, that looks funny, right?
Yeah.
That is, let's say that my x data, since the order of these, it lets you move them around, like you could give this one first and then parameters. You have to tell it what you're giving it here. And so this is just telling it that the x values are equal to this variable.
Okay.
So I'm going to change it to x data. Maybe that's a little less confusing, but that means that my x data, which is up here, that has to be x data. So that's where I'm generating the x values. Does that make sense?
Yeah. Do you have to do the same thing for y?
No, you don't, except I'm going to mess all this up now. So now I have to put x data everywhere. I'm just going to leave this back to x, and I'm going to change it down there. Where were we? Yeah, so this is x. So it's called x up there. That's why it says x equal x. You don't for the y only because the first value that's in this fit function has to be y.
Gotcha.
That's why. So that's why this doesn't say y equals, although I think if you do y equals y, I'm not sure if that's gonna yell at me or not. Yeah, I don't like that. Yeah, so that one you just give it the y.
Gotcha.
Yeah. Now, if I move this over before parameters, I might be able to just put x in. I'm not sure. It's best just to leave it like that. Let me see the format of parameters. Okay, just wondering. So these parameters that we set up, we wrote it like this. This command, add many. This is actually what it looks like. So that's the values that are defined. This is what it looks like internal to this lmfit routine. So fortunately, we don't have to worry about that. We just go ahead and define them like this. All right. And then, so then here we're just go ahead and we're just plotting everything together. So that's our x and y data from up top that we generated. This one is it's taken the best fit from this result. So I'll show you what that looks like. So when it does the fit, it kicks out a lot of different things. Well, let me just do result. So results got a bunch of stuff in it. It's got some statistics, and we just didn't bother playing with all that. It's got the variable names, and then now it's got the actual fitting values for them. Okay. And if we do result best fit, did I do, where is it? I don't need those. If I do best fit, it will actually generate a list of Y values to go along with this X that it already knows about. So that's what's happening here. This is I'm giving it the X we generated. This here is actually giving it this list of Y values. That's my best. That's what this command does. This one, if I look at components, in our case, we only have one fit. So it's given us the values of that fit, and it's a dictionary in Python. So it's got a label and then a colon. When we have two Gaussians and we're fitting, you'll see an M1, and then down here will be an M2.
Right.
Right. And then, so with the Gauss, with that, then we just can grab this as a dictionary. Then all we got to do is give it the label, and then it'll give us the values out. So that's what this step here is doing. So again, in this problem, we don't need this because this best fit and this are identical, because there is only one. Yeah, there is only one peak. So this is redundant at this point. So we could just, remove it. They're redundant. Yeah, so that's my fit. And then I had it print out the best values. Right, so this one is best fit. That gives you the data list. This is best values. That gives you out the parameters. So that's why this is printed down here. It comes from this. So this now tells me what my amplitude, my mean, and my standard deviation are for this actual fit that's here. So let me see. Let me grab, so where's our fit? Okay. So let's see. I'm going to get rid of X. We already have X defined. And so let's say that I want it. So right now this line that's here, which is this one here, this red line, is our best fit. It's showing up as a line, but this actually has points on it that it pulled out for us. We could show this also by just using these values, because later on, you might want to just simply use these parameters back into our Gaussian function and plot it, right? And I should get back this red line, but that's the way you might want to use it later. Once you know the parameters, you don't need to keep that other list around. And so that's what I'm going to do here. This is set up for 2. I'm going to get rid of all that. So I don't have these anymore. Okay, so if you just want to plot your if you want to just go ahead and use your Gaussian function, this is what we defined. And when we define it, it needs, right here, it needs your x positions, right? And then it needs the amplitude, mean, and standard deviation. And then it'll calculate the Gaussian out. So my x is already defined previously, so that'll just go in here. And then the y values for my plot command then are just generated from that Gaussian function. And so the way I can get them, if I call here, I didn't actually define this variable. Oops. If I set my values, result.best values. So these numbers down here, which we print out, I'm just going to go ahead and save them in values. Run that again. Okay. So right now, values should just be that dictionary. So again, it's a dictionary. And so now I'm going to go ahead and put in my amplitude. So I'm just calling values and giving it the label, my mean, and my sigma. And they just have to be in that order because that's the way we defined our Gaussian function G. So now we're putting in these constants and just calling our Gaussian function and plotting it. So that's the way you can plot ultimately your fit from the result itself, rather than here where we called it from the best fit after we've got done with the fitting. Does that make sense?
Yeah.
Now you're all looking like glazed over.
No, it makes sense. I kind of got that portion of the coding down. I just didn't really understand why what was happening. If you're cool to move on, I have a question about problem 3.
Yeah, that's fine.
Unless somebody else.
Does anybody else have any?
So
Okay, go ahead.
So for question 3, it says to add the first fit and the second fit, and you give syntax as well to help with that. And I've tried doing it and adding the parameters in, and when I plot it, I mean, it just doesn't work at all. And I'm curious what syntax, like,
Right. How do you add these things?
I don't even know.
Okay. That's
Right. I don't know how to add.
Oh, that's for this one. Okay, yeah. All right, so what we're gonna do, I'll show it to you with this, and then we can look at it a little closer. This one here, here. So once we did our fit here, we got those values, right? And we stuck them back into our function and plotted it. Does that make sense?
Mm-hmm.
Let's say that we had a second peak. And this one, I'm just going to make up some values for it. So let's say that for my next one, let's see what we had, 249 here. Let's make it like, well, I'm going to go ahead and keep the amplitude the same. And I'm just going to move the mean. So rather than giving it, 3.9, let's go ahead and give it like 0. Well, let's do -1. So I'm gonna generate another set of data. So it's gonna have the same, again, same distribution, same standard deviation and amplitude, but I'm gonna shift this one off to -1, where this one's at 4. So I'm gonna have this red line, that'll be here, but now I'm gonna have another one that's sitting right over here. Right, if I just plot this, So let me do that, and then I'll show you the adding, because okay. So I get 2 of these, and maybe this amplitude is a little big. I'm going to decrease the amplitude just for fun. Okay, so there's 2. And in your case, you'll have your 2 would be, say, this set of parameters, and your next one would look like this, except maybe this is like the M2 case, like this set here.
Mm-hmm.
So you got this set, and then you have this set. So your line here would really look just like this one, but M2 for all of those. I just generated something randomly. I could also plot, and this is getting to your question finally. I can also go ahead and, I got my X values. I can just simply sum right in here. I'm going to make it black points. So there's the sum of my 2 function values. So as long as your X is the same in all of them, these 2 are just lists, NumPy arrays actually. And so you can just add them. And so that's all it's doing. So that's the way you could add the 2 peaks to get a third. Does that make sense?
Yes, I think so.
In fact, if I keep moving this one over, eventually I should get a nice little peak popping out here. But so that's what it's asking. So in your case, yeah, so in your case, you're going to have one fit for P1, and then you'll have, so when you do the P1 fit, you're just going to do one Gaussian, right? You're just going to fit it to simple one Gaussian, and you'll get your amplitude, mean, and standard deviation values. So you kind of like, put those to the side. That's your P1. And then you could do a single Gaussian to P2. So they'll get another set of 3 values. And in this, I was just calling them, P1 that the author got, because these are the 2 author fits in the paper, and then P2. So this variable here is just meant to store these values out that you're going to get for your fit. I called it vals up here, but this is what you'll have down there. So you just need, when you do your fitting, you'll end up with, a line like this. You can call it whatever you want, but you're going to have a bunch of different ones, so you want to try and keep them separate.
Right.
So that's what those are. So this comes from running the fitting routine one time. This comes from running the fitting routine now again, but using this set of data.
So another question, do we have to have so we're using clicks to follow the original data. Do we have to have the same number of data points for these to be added together?
No, because let's see. Oh, yeah, because I generated, because this was generated data, so everything just did. No, let me see if I can pull up something that will help. All right, so when you run, I guess the answer is yes and no. Let me, okay. Yes, you do. You have, in order to sum them, they have to have the same number of points, but that doesn't mean you need to pick the same number of points when you're pulling the data off. So when you pull the data off, just pick as many points as you need to, make sure you get the curves defined real well, right? Because after you pull all your data off, right, your next step is going to be to do something like calibrate the data for each of those peaks. So you should ultimately have, a variable maybe called calibrated DSC. That would be the overall curve. And then you might have, a variable like calibrated P1 for the author's fit. So this is just purely data. These are the points that you pull off the plot, and then you run through the calibration routine. So these will be your data sets. So when you do your actual fitting up in here, your Y and your X, each time you run through, are going to look something like this. So this was fitting the entire calibration data, right? I'm going to pull off the X values, and I'm going to pull off the Y values of whatever this list is. So when you're doing the fitting, X and Y have to have the same number of points, but it automatically does because you're pulling it right out of your plot points. Does that make sense?
I don't know.
All right, let's do one.
I guess it doesn't have to.
Well, yeah, I want it to. The reason why the number of points you pick, it doesn't matter when you actually get to start plotting your fitted result, because in your fitted result, we're only going to use the values that came out of the fit. And then this X we generate separately. This has nothing to do with the plot points, because here we're just using the values that came from the fit. So for example, let me see if we can do one of these peaks. So let me just get my routine. Probably need my, let's grab the, all right, so I need so that you all have this is the select data function. And then down here is the calibration function. So I'm just going to run this so I have those to use. And then I need go ahead and run my select data. So I ran the select data and called the file. So I think you all got this far, right? Maybe.
Yeah.
Okay, I got a thumbs up over there. All right, so I'm going to go ahead. I'm just going to do one of these peaks. Let me do like P1, and when you do it, you should do it a little more careful than this. It's going to be particularly important when you do the green curve on here, the overall, that you try and be careful and get as many points as you can, especially around this peak area where it sort of dips in there. All right, I'm just going to pull off those points. We'll just go ahead and do that sort of quick fit. So this is for P1. All right, so that is in my, what did we call that? That's here, pixel positions, right? I could spell. All right, so there's the points I just pulled out of there. Once I've got those, it's probably good to go ahead and sort of deactivate or close this interactive thing down. That way, when I plot other things, it won't interfere. I don't need this running in the background. So that'll stop me from clicking on here by accident. Okay, but I have my positions. And so now I'm going to just simply come up with my points. So my calibrated, what is this, P1 data. I'm going to call it P1 for the author. I'm only doing that because when we fit the overall curve, then we're going to also have a P1 and P2 for the two fits, but they're going to be from our date, from us fitting. This is the author's P1 curve. And that's just going to simply be my calibration function. And I guess I need my values for the pixel points, plot points, and then the data. My data in here is going to be, in this case, pixel positions. And I'm going to cheat and grab the plot points that I had from before. Plot points. Yeah. All right, hang on. All right, so I'm cheating. I've got my plot points and my pixel points, and I did this once before when I was being a little more careful. So these values probably are a little bit off from this particular image because I think I used a slightly bigger image or something. But I'll go ahead and use these. So I'm pulling off the 800, the 25.0, and 25.1. So I pulled this one off, 800, 25.0. Oh yeah, and then this scale's arbitrary. So somewhere up here, I probably picked like this spot. I just called it 0.25.1. So it's got a height of 1. So, but you can put your height of 1 anywhere.
So, quick question. Like when I was doing that portion of the code, I figured out that I had to have a Y value, and I put 10. Is that gonna be a problem, or
no? That's fine.
is it cool?
Yeah, it shouldn't be a problem. Your amplitudes will just come back 10 times bigger. It's arbitrary anyway, so it shouldn't matter.
Right.
All right, and then these were the pixels that corresponded to those. So I'm going to need those in my calibration. So my calibration is, I forgot again, which one comes first? Pixel points, then the plot points. Okay. So I got my pixel points, my plot points, that calibrates it, and then my positions. When I was careful, it's actually this variable here. So I'm just going to get rid of these two so they're not getting in the way. But these are the points for the P1 peak. So I'll go ahead and put that data in, and I'll get my calibrated data out. All went well. Then I should be able to put in, just double check here. So that's my X. My Y. That'll look good. Oops. Yeah, that's not my Y, it's 0. I gave it X and X. X, Y. Okay, There we go. All right, so that's my P1. That's my P1 set of data. There. Okay. So, all right, so now we actually have some points on here. And again, my points, this is P1. If I did this for P2 and then the overall curve, I have 2 more sets of data. And the number of points in these 3 sets of data are completely different. So it doesn't matter how many points you pick. You just want enough to define it real well, but they definitely don't have to be the same. So, all right, so let's go ahead and fit this one. So we're going to fit, I'm going to grab this variable name so I don't forget what it is. Okay. So we're going to go ahead and fit it. We've got our, it's a single Gaussian in this case, so we'll go ahead and use that single Gaussian. We got our model. We're going to need to change the parameters, but before I get there, in the fit, I need the Y data. Right, in our case, the Y data is now, right, it's the second position or 1 for this parameter, and my X is now that one. So these 2 have the same number because it's the same data set. So I'm going to put my X's and my Y's go up front. So that's the only change to this piece. And then I got to fix my parameters because these are not right at all. So mean, like 220, the width here, you know, it's 150 or so. It doesn't really, you know, again, the idea is you want to give it a mean that's not like 1, which is completely off. So I'm just sort of roughly saying about halfway. So from about here to here, you know, it's a little over 100. Or even 100 would be fine. And the means, you know, somewhere like 220 or something. So I'm going to fix that. So my mean is 220. My width here is 100 or so. I'll just put 150. And then the amplitude. So that's where remember the amplitude is going to be the standard deviation value sigma times the square root of what was it, 2 times pi? Yeah. And then that's the factor, and then that whole thing times the amplitude I want to get, which in this case is like 0.5, right? So in your case, it's probably more like 9 or 7 or something. But mine, you know, again, I'm not getting real particular because this is just a guess for it. So it's up there around 0.6, 0.7. All right, so it tells me I should be guessing something like 220 for my amplitude. 225, I guess, is fine. I don't want to be, definitely don't want to be limiting it between 0 and 10 because I'm already at 220, which is outside that range. What I'm going to do is, I guess I'll leave the 0 in just to tell it the minimum. We can't have a 0. Well, we could have a 0 mean. We don't in this case, but heck, I'll just get rid of all of them. I'm only going to give it initial. So I'll just give it initial values, that's it. All right, and that should be all I need to fit that. Okay, this one here is actually plotting my XY data. So I should, I should in here tell it what X and Y are in this case, right? We already did it down here, but that's just for the fit. Okay. And so I did that only for this command line here, which is going to plot our original data set. And then this one's going to actually plot the fitted result over top. Yeah, let's see what happens. What did it do? Put it up here because of this. Okay. Yeah. This is why, yes, I didn't close this one down. It was still active. So I ran a plot command down here and it went up and shoved it into this figure. So let me just close that and run this again. All right. So there's my output from this one. One way to avoid this, since we're not trying to pick points and all that, so I don't have to keep shutting this down. For this particular case, I could go up here and tell it to do matplotlib inline. That's what that command does. So now if I run this, it just puts it here. It's not active. The matplotlib notebook is what you need it in order to interactively be able to pick points. Okay, but that's my one fit. So what I want from this are these three values. So those are the three values you want to save as the fit to the author's P1. And then you could do it again for the author's P2. And now that you're using these values, we can, let me just bring it down. Here. All right, so that's our fit with these best fit parameters. It's called values right now. So this, remember, make sure you change this to something like that's specific to this curve, like P1 author or something, because when you run it again, you don't want to overwrite your variable if you call them all values, because you want to be able to refer to them. Okay, so again, that's just these. So in your case, instead of this being values for both of these, one of them would be like, P1 author, and these down here will be P2. But you're going to, again, just call these for that set. And let's see, in fact, if you use this twice, let's just do this. Let me do that because I'm going to go ahead and we'll call it P1 author. That's fine. All right, so that's what's here now. So these should all say P1 author.
So that's exactly what I did for that portion. But
Yeah.
when I plotted the summation curve, it's way different than the DSC data. Like, well, it's not it's just way taller.
Okay. It shouldn't be. Well, it's possible, I guess, if it's possible if your fit's off, and we could play with the starting values, and it may get better. So let me try this for this. So for this one, if I run this whole thing again, but now let's now we've got everything pretty much here. We can fit this in. Let's call this is P2 data. All right, so I have the P2 data. So now I could run this again with the P2 data. Make sure that I'm fitting the P2 data. And now my result will come out and I'll call it P2. Okay, so there's my P2 fit. So now in here, I've got P2. 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 And what I didn't change up here is I didn't tell it to use a different prefix. It's still prefix M1, right? Since I'm using the same thing. So I just have to remember that because then here these need to be M1 as well. Okay. All right, then sum them, then do. What's my, oh, I didn't fix my scale here. So this is, so this is where your X values have to be the same. All right, I'm feeding these into my function, so I can feed as many X values as I want in there. So that's why I have to define them here. And in this case, my limits are supposed to be, I'll make one limit 0 and the other one like 850. Okay. So that's what I'll get for the P1 and the P2 for the authors, and then the blue curve is just simply summing them directly. And then the other thing I could plot on here is the actual original data, right? My let's make sure we've got that too. My DSC, that's the whole curve. All right, let's make sure we've got that. So that's called DSC. All right, so I'm going to go ahead and calibrate it and get my points out. I'm not going to fit it or anything. I'm just going to plot that data directly on here, calibrate it, DSC data. So these are just my points. That's my X values and my Y values. And let's just make these black points. Yeah. So that's the author's fit to the data set. So these somehow aren't adding up right with yours, right?
They keep telling me that I need the dimensions and the shapes of the matrices have to match up. So I think I'm doing something wrong.
Yeah, when you're adding them here.
Yeah.
When you do this step here, feeding it back into the Gaussian, are you giving it the parameters back? I mean, you're giving it.
I'm giving brute. So I copy and pasted the values in because I wasn't letting me index. Maybe I could get it to index again.
Okay, but in terms of what you're doing, you just copied and pasted these in directly.
Yeah.
Okay.
Oh wait, actually, I realized what I did wrong. I had the wrong X data. I fixed it.
Okay. I was going to say that the only other thing is, as long as you generate the X again, and these are both using the same X, that's the dimensions. So they have to be the same.
I got it to work out.
Okay, good.
All right. Well, I think that was my last functionality question. Everything else, I was just curious on why things were being written the way they were.
Yeah. Yeah, it's definitely important to know. I mean, this is, if you're going to fit anything later, you got to kind of know what's going on with this, you know. So I definitely want you to know, what steps are there. But we've really written this in the most general sense so that no matter what your data is, as long as you can define a function, you should be able to fit it.
Right.
Whether it's got, multiple curves or if it's a single curve. And this deconvolving peaks from a set of data is one of the more challenging problems. Doing a straight single fit to a peak is not bad. It's trying to get this deconvolution that's difficult. And what you're going to see in this problem, as you go through the rest of the problem, which is going to ask you to next, it'll ask you to go ahead and fit, the actual black points yourself, right? We didn't actually fit those yet. So this blue curve is just summing the authors P1 and P2.
Correct.
We'll do an actual fit on the black, and that's when we'll use the two Gaussian functions.
Wait, didn't it ask in problem 2 to fit the DSC data?
Yeah, okay, yeah. So you've done that already then.
It wasn't a good fit. At least mine wasn't.
If it didn't give you a good fit, then you might want to check your start values because it should do a better job than the authors actually have.
Really?
Yeah,
All right.
I can show you.
Well, I understand how this all works now.
Yeah, let me just give you an idea. Yeah, this is my fit to the black data points or blue data points here. And you can see this is the author's fit. It does a much better job, in these regions and in this region as well. It does a much better fit.
What is it, the black line?
The red one, the red is the overall fit. The black and the green are my P1 and P2s, which you can see are quite different than they got in the paper.
Yeah.
But the overall fit is better on the, especially, on the two ends. This red curve does a much better job of fitting these data points.
All right.
You might just tweak around with your starting cases. It's pretty sensitive sometimes to the amplitude you give it to start. If your amplitude isn't big enough, it can kind of throw it off.
Yeah, I've noticed that.
But it should do a pretty good job of, one way to do it is if you're sort of close to the fit, depending on how close you are. If it's terrible, then, but I'm gonna say if these peaks are just a little off and it's not the best, you could then take those values that you got and put those back in as starting conditions.
Yeah.
And run it again. But yeah.
All right, well, thank you for answering all my questions. It's been
Sure.
really helpful. I appreciate that you took time out of your day to do that.
That's no problem. And then you're okay with this last part then, I hope, which is using the
I'm
Avron.
sorry?
I said, then hopefully you're okay with this very last part. You probably didn't get that far to read it. But that's to go ahead.
I read it. I hadn't gotten to it yet.
Yeah. Okay. Because that one, you're just simply, you're going to,
I figured.
you're just going to repeat the two Gaussian fit that you just did. It's just now you've got a different function. And your parameters are now A, B, and N instead of A, mu, and sigma. That's really it. You just simply use that. And then you should ultimately get an even better fit. But
Yeah. Yeah, I think I'll be able to do that fine.
All right. Yeah, this is giving everybody a little bit of headache.
All right. Yeah.
All right.
All right. Thank you so much.
Yep.
Have a good one, man.
All right.